Okay, welcome to our extra fun example problem. I am video recording this one. Yes.
Everybody.
Start over.
No, we'll go ahead and capture that. All right, so we're going to find the derivative. We're going to find the derivative of f of x equals the square root of x. So let's go ahead and start plugging away here. We have f prime equals the limit as h goes to 0 of, we have the square root of x plus h, minus the square root of x all over h. And you're like, let's see here. What could I possibly do? What the heck is going on here? What could I do to simplify this problem? There's not really a whole lot you can do, except you can do something called rationalize the numerator. You see, I'm trying to get rid of my division by 0 problem. And I can accomplish that goal by rationalizing my numerator. So I am multiplying by the conjugate of the numerator. Okay? Okay, so we need to multiply. And we have, essentially up top here, we have like a difference of squares, right? When you multiply a difference of squares, essentially you just multiply the front and the back, right? You guys remember that? Should I refresh your memories real quick here? Yes, real quick. X minus 5 times x plus 5. You know, if we multiplied that whole thing out, we'd end up with x squared plus 5x minus 5x minus 25, and so we just end up with x squared minus 25. And so what I'm saying here is when we have a difference of squares, we could just not even really think about that middle part and multiply the front and multiply the back, right? So that's what I want to do right here. I just want to multiply the front and the back, okay? And so we have the square root of x plus h times the square root of x plus h, which is going to give us just x plus h. And then we have to multiply the back there, which is going to give us a minus x. And this is all over h times the square root of x plus h plus the square root of x. And at this point here, we have a minus x and a plus x. These guys cross each other off. And lo and behold, by rationalizing the numerator, we end up being able to cross off some h's, which gets rid of our division by 0 problem. All right? So we have the limit as h goes to 0 of 1 over square root of x plus h plus the square root of x, and there's nothing else we can do here except to just plug in h equals 0, and so we end up with, we have a 1 over the square root of x plus 0, which is just the square root of x plus the square root of x. And these are like terms, and so we can combine them, and we can write a 1 over 2 root x. And that is the derivative of that particular function. And if we want to get really fancy here, you know what we could do? We could rationalize the denominator if we wanted to. Yeah, and so if we wanted to get really fancy, we could say, let's rationalize the denominator. And that's going to give us root x over 2x, right? But, you know, I think this is perfectly acceptable. Do you guys want to do one more? Or?
Do you feel ridiculous when you talk to yourself on these when you're like alone in the classroom? Like when you're just like talking to, he's like talking to himself on the thing when
How do
there's
you
no
know
one else
there's
in
not
here.
someone there?
Because with well, I listened to that by choice. I don't know.
It's
I
just-
don't know. I was assuming.
That's what every single document today.